Hello once again, and in this section we will be learning on how to find the number of intervals corresponding to a particular class width. In the two table examples that we have table 1, which has about 4 class intervals, and table 2 has 12. Now you might actually have questions like, so how do we decide on how many class intervals would be there for a particular data set? Now, in trying to decide which size class interval to use, you can use a quick way to determine how many intervals you will wind up with for a particular interval width. First, step 1, we need to find the range of the scores by taking the highest score in the array, in this case, which is 99, and subtracting the lowest score, which is 60. Actually, you can start with the upper real limit of the highest score and then subtract the lower real limit of the lowest score. So in this particular example in table 1, we have 99, so we just add 0.5 to 99, so we have 99.5 minus 59.5, which is our lower real limit in this particular example. So if you subtract 99.5 minus 59.5, that would actually be equal to 40. So now, step 2 tells us to divide the range by a convenient interval width and round it up if there could be a possible fraction. Now let's try to divide 40 by 10. So that could be a convenient interval width. So basically, if you divide 40 by 10, we would also be having 4, which is now equivalent to our class interval. We have about 1, 2, 3, 4. We have 4 class intervals in this particular example. Now moving to the second table, we have the upper apparent limit of 98, and then that's the highest score, and we also have the lowest score or the lower apparent limit, which is 63. Again, we would do the same procedure. We would be getting the real limits by subtracting the real limits. So the upper real limit, which is 98.5, and then subtracting it with 62.5, which would actually be resulting into our range. Now 98.5 minus 62.5 is equivalent to 36. And if you would divide 36 by a convenient number, which is step 2, we could be dividing 36 by 3. As you can see in our interval width. So we have 96, 97, and 98. So there is about 3 for our interval width. So we divide 36 by 3, and that would be equal to 12. So we now have a class interval which is equivalent to 12. So we have this first 6 class interval, and then the other is the other 6. And there is also a note being reminded by statisticians To avoid having too many intervals with low or zero frequency, it has been suggested that the number of classes not be much more than the square root of the sample size. So in this case, we would just be looking into the frequency, and if we would be totaling everything from the frequency, we would be arriving to a sum total of 25 entries or data. Now, n is equal to 25, and the square root of 25 is basically 5. So we may actually have 5 classes, for example, in this particular example. And this could be another way in also trying to identify the number of class intervals in a particular grouped frequency distribution. Another way to help us decide on a class width to use is to first find the range of the scores by subtracting the lowest score in our distribution, and from the highest and adding 1. Then we would divide the range by a convenient class width, just like what we did previously, and round up if there is any fraction to find the number of intervals that would result. If the number of intervals is between 10 and 20, the width is probably reasonable. Otherwise, you can try another convenient value for the interval width. However, you may want to use fewer intervals if there are fewer than 100 scores in your distribution. Now, at this particular part, we would also be talking about choosing the limits of the lowest interval. Having chosen the width of your class interval, you must decide on the apparent limits of the lowest interval. So the rest of the intervals will then be determined. And naturally, the lowest class interval must contain the lowest score in the array. So for this example that we have in table 2, the lower limit of the lowest interval is 63, and it is just a multiple of the interval width, which is 3. It would also have been reasonable to start with 64 to 66 as the lowest interval, because then the upper limit is 66, and 66 could also be a multiple of the interval width. Now, choosing the limits of the lowest interval is a matter of convenience, and a judgment can be made after seeing the alternatives.